Hello everyone, let's move on to the next design question. Estimate the main dimensions of a 10 HP 400 volt 50 Hz 4-pole induction motor having the following data. D average is 0.45 Weber per meter square, ambient conductors per centimeter is 220, efficiency is 0.9, power factor is 0.9. Determine also the conductors per stator phase when the stator is star connected and delta connected. So let's move on to the design. So first we have to find the main dimensions. Main dimensions is D and L. So let's take the output equation. Q is equal to C0 D square L NS. We have to find out D and L. So first let's find the input kVA Q. Q is equal to output, that is output in HP, that is 10 into 0.735 divided by efficiency into power factor. That gives the input kVA. So let's find out what is Q. So 10 into 0.735 divided by efficiency is given in the question as 0.9 and power factor is given as 0.89. So we'll get Q as 9.176 kVA. Now we have to find out the output coefficient C0. C0 is 11 B average AC kW into 10 raised to minus 3. So in the question B average and AC is given but the winding factor is not given. So we can assume kW as 0.955 if it is not given in the question. So 11 into B average is 0.45 into ambient conductors per centimeter is given as 220. So ambient conductors per meter is 22,000 into winding factor is not given. So we are assuming it as 0.955 into 10 raised to minus 3. So we'll get this as 104. Now we have to calculate NS. Q is equal to C0 D square L NS. NS is the synchronous speed in RPS. So NS is equal to 2F divided by P. Frequency is given in the question as 50 Hz and number of poles is 4. So this is 2 into 50 divided by 4. That is, you will get it as 25 RPS. Now we can write what is D square L. D square L will be equal to Q by Z0 NS and Q is 9.176 divided by 104 into 25. So we'll get that as 3.5 into 10 raised to minus 3. Now we have to separate D and L. For that, the L by 2 ratio is not given in the question. So if nothing is mentioned, we can assume for good overall design L by 2 is 1. So if nothing is mentioned about L by 2 ratio, we can take it as for good overall design. That means L by 2 ratio is equal to 1. So that is, tau is the pole pitch. So L by pi d by P is equal to 1. So we know the value of number of poles. So we can write L is equal to pi d by P. So we can substitute that over here. D square L is equal to 3.5 into 10 raised to minus 3. So instead of L we can give pi d by P. So we will get D square into pi d by number of poles here is 4. That is equal to 3.5 into 10 raised to minus 3. And solving you will get D cube as 0.00448 and you will get D as 0.1649 meters. So now you know the value of D. Now we can find L. L is equal to pi d by P and you will get the value of L as 0.129 meter. So we have found the main dimensions. Now next part is to find the conductors per stator phase when the stator is star connected and when the stator is delta connected. So first let's consider when the stator is star connected. So we have to find the conductors per stator phase. So in order to find the conductors per stator phase, we have to find the turns per phase. And turns per phase, we will get it from the EMF equation. E phase is equal to 4.44 F5 kW into TPH. And we can find TPH from here, but we don't know the value of flux per pole here. So in order to find flux per pole, we know that B average is equal to, that is the specific magnetic loading, that is equal to P5 divided by pi dl. From this, we'll get flux per pole phi as B average into pi dl divided by P. So B average is given in the question as 0.45, that into pi into D is 0.1649 into 0.129 divided by 4. So we'll get the flux per pole as 0.0075 Webers. So now we can write what is T phase. T phase is equal to E phase divided by 4.44 F5 kW. So here the voltage is given as 400 volt and we are considering the case when the stator is star connected. So the relation is line voltage is the root 3 times the phase voltage. So line voltage is given as 400 volt, VL is 400 volt. So V phase or E phase is equal to 400 divided by root 3. So 400 by root 3 divided by 4.44 into frequency is 50 into flux per pole is 0.0075 into 0.955. So we'll get the turns per phase as 146 turns per phase. And so we are asked to find the number of stator conductors per phase. Therefore, number of stator conductors per phase is equal to number of turns into 2, that is 146 into 2, that is 2 conductors makes 1 turn. So number of stator conductors per phase is 146 into 2, that is equal to 292 conductors per phase. So this is the number of stator conductors per phase when the stator is star connected. Now we will consider the second case when the stator is delta connected. So E phase is equal to 4.44 F5 TPH into kW. T phase is equal to E phase divided by 4.44 F5 into kW. So here we have found flux already. Now E phase is, here the stator is delta connected. So line voltage and phase voltage are equal. So 400 divided by 4.44 into 50 into 0.0075 into winding factor is 0.955. So we'll get it as 251.56. So it's approximately 252 turns per phase. Now the number of stator conductors per phase is equal to 2 times the turns per phase. (252) into 2. So that is equal to 504 conductors per phase. So we have found the main dimensions and the number of stator conductors per phase when the stator is star connected and delta connected.